And we'll be able to see how long this takes me as well. So question 1, which we've noticed is a simple familiar, it is worth 2 marks. That was noted on the end. So just be careful of doing the whole thing on your calculator with 2 mark question. F of x equals e to the x over cos x. 2 marks means that I probably need to show the derivative and f of pi. So I'm going to do the derivative first. F dash of x will equal u dash v minus v dash u over v squared. It's only worth 2 marks, so I'm not going to muck around with this. U is my top one, so u dash is e to the x, v is cos x, minus v dash is negative sin x, times u, which is e to the x, all over cos squared x, and this is equal to e to the x out as a common factor, cos x minus sin x, all over cos squared x, and f dash of pi, yes, it should be plus, sorry. F of pi is equal to e to the power of pi cos pi plus sin pi over cos pi squared. And cos of pi is -1, sin of pi is 0. So I get e to the pi times -1 over -1 squared, which is just e to the pi, but with a negative at the front. So that's your calculation there. You can do that pen and paper, you can do that in your calculator as well, just as easily. So if I go into my calculator here, into the run matrix screen, there, I can just press 1 to go in there as well. I can determine the derivative at a point. I go math, I go d dx, I want d dx of the function e to the power of x over cos of x, and I want it at the point. It won't tell you the derivative as a function, but it will tell you the derivative at a point. So it doesn't have CAS functionality, and it tells me that, which is not overly helpful. If I do this, it might not help me, but I can now just check my answer, e to the pi, and I get the same answer, but negative. I've done that check. So you can do that check. If you get a answer like that and you suspect that maybe there's a nice neater answer and you can't get it for calculator, this isn't a hard calculation to run through, so just quickly evaluate those. It's going to move in a second. Okay, let's go back here. There we go. Okay, second question. F of x equals x squared plus p over x. This is a multiple choice question. Yes? Well, like I said at the start, the first mark will be allocated for the derivative, the second mark for the actual value. Second question. This is a multiple choice question, so I would expect you to be looking for opportunities to use technology in this question. Now, you might not have an opportunity to do a straight technology answer, but for those opportunities, there's only 1 mark allocated for the multiple choice. So one thing you could do with multiple choice is just check these numbers and see what happens. But because there's 5, I suspect actually working out is going to be better. So consider f of x equals x squared over plus p over x. We want to find the stationary point at x equals -2. Find a value of p that makes that work. So I'm going to say, and the working doesn't matter in this type of question, f dash of x equals 2x minus p over x squared. I've done heaps of these 1 over x derivatives, and I know they end up being -1 over x squared, just with a p in this case. You might need an extra step there. Right, there's x to the power of -1, that's fine. But I don't really care about working at the moment. This is equal to 0 when x equals -2, so it's p over -2 squared. If I add the 4 to both sides, I get 4 is equal to -p over 4, and therefore p is equal to -16, and so the answer is A, 1 mark. Connor.
Why do you get -p over x?
Oh, sorry, that's my fault. Translation error. I'm feeling the pressure more than normal when I'm doing it in front of you guys. E is 16, so E. My apologies. That's the derivative. Okay, cool. Any other questions? Okay, question 3. So this question seemed to get a couple of people, and so you need to You read the question because it says Jamie's approximation as a fraction of the exact area. So first of all, you have to work out the area approximation, and that's just going to be equal to the area of each rectangle added together. You don't have to do any special work. The information's in the diagram. It's multiple choice, no calculations required. So I've got 0 to pi on 6 gives me a width of pi on 6, and I can see these widths are the same. If you're familiar with those pi on fractions, you'll know that gap. So I get basically pi on 6 times 4 plus pi on 6 times 2 plus pi on 6 times 1. I probably wouldn't even write that answer. I just pi on 6 times 4. There's 4 of them, there's 2 of them, there's 1 of them. So there are 7 of them in total. 7 pi on 6 is the approximation. The actual area, I'm going to go into here. It's an integral. So I'll jump on here. I go across to my integral value in the math screen. I want the integral of 2 cos brackets 2x close brackets plus 3, and I want that integral between the boundary of 0 and pi on 2. So pi on 2, and you should be quicker than that because you've got it in your hand. And so the area actual is equal to 3 on 2 pi, and therefore the area approximation over the actual area is equal to 7 pi on 6 over 3 on 2 pi, and if I run that calculation I get 14 over 18, which is 7 over 9. A rich conversation I had during the formative was that E, maybe others, but definitely E, has a value that's greater than 1. And you can see this as an underestimate. So the area approximation as a fraction of the overall area has to be less than 1. You can wipe E out straight away. When you're doing the multiple choice, and particularly when you're practicing, we'll hit more of them in term 3 because multiple choice doesn't come up in your IA 2 or 3. But after you've done IA 3, we'll do lots of multiple choice practice. When you're practicing them, look at how you can wipe out some of those possibilities because there'll be obvious incorrect answers. Well, partly obvious. Question 4. Differentiate. This is a 2 and a 1 mark. So again, it's a pretty short question. Differentiate log x squared. So I want to do d dx of the natural log of x squared, and that's equal to 2 natural log of x times by the derivative of the inside log x. That's going to get you your first mark by showing the first step, and then that will become 2 over x log x. That's the second part, which will get you your second mark, the final answer, because the derivative of log of x is 1 over x. That should say equals, so that shouldn't be read. Any questions on that one? If you get a question like this that says, by first deriving, determine the integral, which is what this question does, well, that gives you a pretty good hint that the integral is going to lead back to the thing you derived in some shape or form. So what this tells me in part 2, and it's only worth 1 mark, is that the integral of 2 over x log x dx is equal to log x squared, and therefore the integral of log x over x dx is equal to 1/2 log x squared. So I've just divided through by 1/2. You know, they've placed that log x on top of the fraction, but it's the same thing. Okay?
Do they plus c?
Yes, we do plus c. You know what? Let's be honest though. This is a 1 mark question. Yes, you can in a minute, Xander, but not now. This is a 1 mark question. Probably the plus c is not going to be worth anything in this question. If it's a 3 mark integration question, it might be worth 1/2 mark. So we're not going to hit you every time, but sometimes. Question 5. The derivative of the function y equals f of x is given by that. So you've got the derivative function. Find the x value of the 2 stationary points for that function and determine the nature of the stationary points. 2 marks again. Don't fall into the trap of thinking you have to derive. They have derived. Just need to say for part 1, f dash of x equals 3x squared minus 2x minus 1, which equals 0. Again, I told you could rely on technology if you wanted to. So your first mark is for that recognition, and your second mark is for working out on technology, which the solve function's on here too somewhere. So if I go into options and calculate, I can solve in here, or I can solve numerically in here. Solve numerically is pretty quick, and so I can put straight into here 3x squared minus 2x minus 1 equals 0, and I think I have to put a comma x there. And then that'll come up, but don't worry too much about that. It'll tell me the two solutions, and it's just having a proviso to say there might be more solutions. Yes?
It's supposed to be plus 2x.
It's supposed to be what, sorry?
Plus 2x.
Oh, okay, my apologies. Okay, so delete that. Just be careful with these. Exit. And my answers are x equals -1 or a third. And it says determine the nature of these stationary points, and that comes from f dash of x, which is equal to 6x plus 2, and f double dash of -1 is equal to -4. F double dash of a third is equal to 4, and so therefore this is a maximum and this is a minimum, and so actually I don't think you get a mark for that. You get your mark for each of these and for each of these.
Can you say positive in nature and negative in nature instead of maximum?
You could, but it's better to identify whether they're a maximum turning point or a minimum turning point. Saying negative or positive is just taking whether the second derivative is negative or positive. Any questions on that? I would say if you got that question in one of our exams, it would probably be worth 4 marks, not 2. But that level of working there would pretty much get you the marks anyway. Question 2, a curve passes through 0, 4, find an expression for f of x. So we've got f dash of x is equal to 3x squared plus 2x minus 1. And this is nice, 3x squared. You got the 3 there already. That means that f of x is equal to the integral of 3x squared plus 2x minus 1 dx, which is equal to x cubed plus x squared minus x plus c. And we also know that at x equals 0, y equals 4, and therefore c equals 4, and we get f of x is equal to x cubed plus x squared minus x plus 4. And again, we'll allocate the marks here for getting to this stage and then for determining the value of c. So those first 2 marks will be for the 3 of those, half a mark for 2 of them, correct? And then determining c. Any questions on that? Question 3, I've not given myself enough room, but question 3 is hence sketch the curve. So again, I've told you to do this speed. So if I was sketching this curve, I know the original curve is a cubic. I don't know where the original curve crosses the x-axis. I could solve that, but before I do that, I might just plot everything else. I know that it has a turning point at -1, and that turning point is a maximum, and another turning point at a third. What I might do is go through and find some important information. So I'm going to do another solve n here, and this time I'm going to solve that cubic and see what comes out as my x-intercepts. So x cubed plus x squared minus x plus 4. I'm going to let y equal 0. That's not what I wanted. Plus 4, shift equals 0, comma, x, close brackets, execute, warning, press exit, and there's my solution. I've got one solution and it's here. I suspect it's probably an irrational number and has a square root representation, but this will do. So I write -2.24. That means that because it's a positive cubic, it comes up like this, goes to a maximum at -1, it goes to a minimum at a third, and then it keeps on going like that. So that's a third, that's -1, and that's -2.24, and that information is enough. Can anybody tell me what my y-intercept is? 4. So that value is 4. And I've put enough information on there. Make sure you label your axes Y and X, and we're good to go. Put an arrow probably on both ends is better because it does go on each way. Yep.
Do you need to have that X to root?
It's a 2-mark question, so in this case probably not. But if it was worth more, you might need it. And because I didn't know enough about the function to feel confident drawing it, I've decided to get it. It cost me 30 seconds.
But if you found the Y values for the map,
Then that would be pretty good as well. Yeah, you could do that as well. But I thought in this case the root's going to be quicker to find. Yep. Baxter.
I used the quadratic method for the stationary points, but it came out completely different.
Do you mean for part 1?
Yeah. Going way back.
Use a quadratic formula?
Yeah.
Can I check your working later? Is that all right? I'm on the clock and on a video. Okay, question 6. A particle is moving along a straight line. The particle is initially at rest. Initially at rest means that time equals 0, v equals 0. That's what that means. The acceleration of the particle is given by A equals e to the 2t minus 4. Find an expression in terms of t for the velocity. So in this case, the velocity is equal to the integral of the acceleration with respect to t, which equals the integral of e to the 2t minus 4 dt, and that's equal to a half e to the 2t, that's an x, minus 4t plus c. A half, when I integrate that e to the 2t, I have to divide by the derivative of the inside function. Divide by the derivative. There we go. Tongue twister. And I also know that at t equals 0, v also equals 0. So I get 0 is equal to a half e to the 0 minus 4 times 0 plus c. E to the 0 is 1. Half of 1 is half. C therefore equals negative a half. And that leads me to velocity equals a half e to the 2t minus 4t minus a half. Any questions? And the last question, worth 3 marks, and this was good because it was interesting to see Connor came down to his last 30 seconds and proved to me that he could input this into his calculator and get the actual answer out in 30 seconds. He doesn't get the first 2 marks, but he does get the last mark. So use your time wisely, particularly at the end of an exam, particularly if you haven't quite finished. We know the boundaries, we know the function. This is a question that is by first deriving this, calculate the integral of that, except you're not given the by first deriving. So this question, if it looks like it's in quotient rule form, then it's probably something like this, f dash of x over f of x. And when we integrate f dash of x over f of x with respect to x, we get the natural log of f of x. So I suspect, and plus c, that if we integrate 3x over x squared plus 1, we get the log of x squared plus 1. Although if I derive x squared plus 1, I don't get 3x. So the top shouldn't be 3x. That's where my problem is. So I'm going to first start by saying f of x equals equals log of x squared plus 1. So I know my stuff. I can see it's an f dash of x over f of x. So I'm going to put this in as a log of the denominator, and I'm going to derive that to see what I get. That gives me 1 over x squared plus 1 times 2x, which equals 2x over x squared plus 1. But I'm actually being asked to integrate 3x over x squared plus 1 dx between the boundaries of 3 and 0. How much bigger is 3x than 2x? It's 1.5 bigger. So what I can do is I can say, well, this is equal to 3, the integral of the integral of x over x squared plus 1 dx between 3 and 0. Still not quite right. That's equal to 3 over 2, the integral between 3 and 0 of 2x over x squared plus 1 dx. So what I've done is, this is called the unitary method. I've taken the 3 out just to make it a unit and single x on top. That's still not right though, because this calculation here tells me that the integral of 2x over x squared plus 1 dx is equal to the natural log of x squared plus 1 plus c. So this is still not right, so I had to divide the outside by 2 so I could get a factor of 2 on the inside. And now I get this, 3 over 2, and then natural log x squared plus 1 between 3 and 0. And that's equal to 3 over 2 log x squared plus 1 is 10 minus 3 over 2 0 squared plus 1 is 1, and that gives me 3 over 2 log 10 and 3 over 2 log 1. Log 1 is just 0. What to the power of, sorry, e to the power of what equals 1, and the answer is 0, so I just get minus 0, and this is my answer here. 3 over 2 log 10, I could work it out as an exact value, as a rounded value, but I'm going to leave it like that, and you can test to see if your answers matched it.